your source for JVM knowledge.
Welcome to my talk. This talk is going to be about Amazon Web Services and Micronaut and how they play together very nicely. My name is Vladimir Orany. I work for a company called AWS, which is now the proud sponsor of ReachCon this year. You can find me on Twitter as Musketeer. What I do most of the time, I do stuff around testing, but I do some R&D, and I'm responsible for the functions, now Micronaut Functions in our company. So let's start. Well, I have heard that someone was snoring about during the talk. So if you want to sleep, just sleep. It's okay. Just don't snore. Okay. Okay. So what we are going to talk about? It's pretty simple. It's going to be very practical. Also, there won't be a lot of live coding, so you can see a lot of snippets. You don't have to try to read all of them. You don't have to try to understand all of them. You can just take a look on the presentation later on and try it yourself at home. So the first thing is the way how to run Micronaut on the AWS infrastructure. Then we take a look on the libraries we created in AWS to help working with AWS SDKs, some of the services in an easier way, and just, of course, a summary. So Micronaut AWS support. So is there anyone in the room who wasn't on the Micronaut talk in the morning? So you know that Micronaut is awesome. Micronaut does everything much better than the other frameworks. And it's natively cloud native. I stole this from the Micronaut website. So you can see it's built for a cloud. And I think we can say it's built for the cloud billing, because if you run anything in the cloud, every bit of memory is costing you more money. And you can see AWS is already mentioned here on the website, and it's quite built into Micronaut, especially for into Micronaut Functions. So just in a brief, what is Micronaut Web Services? These are some logos of the services. I don't think there is anyone who can count how many Amazon Web Services out there, because it looks to me that every time they just start a new service. But these are the core ones. There's Amazon Beanstalk we're going to talk about. It's the way how to deploy your stuff in the old way. There's the serverless toolkit Lambda, and these are the services we have the support in the library, which is Amazon Simple Email Service, DynamoDB, which is Amazon's document database, API Proxy. This is the thing which is basically converting the HTTP request to Lambda calls and back again. Streams, Kinesis streams, simple queue service, simple storage service, or S3 to store upload files from your application, and simple notification service. So you can see everything is very simple in Amazon. Hopefully. That's the reason why people start to be Amazon engineers as a separate job. Okay, so AWS Amazon Beanstalk. I still believe Amazon Beanstalk was kind of response on Google App Engine. So basically, in Java world, so probably in Java world, what you wanted to do is just build your WAR file and deploy it somewhere and don't care about anything. So I think Google App Engine was the first. Amazon Beanstalk, I think, was the second. And you can use a lot of languages. Java, you can use Go if you want to be really fast, as we heard before as well. And of course, you can use Docker, which helps a lot to run it in the way you want. But I just pinpoint this to logo, so we're going to talk about Java. Of course, we're going to talk about Docker. So let's start with Java. I think that's the only one demo I can do, because if you have a conference or if you're doing the live demo, it's always like a box of chocolate. You never know what you're gonna get. So create an application in Micronaut is very, very simple as long as you have the CLI. So create application, breach, and it doesn't work. Create app, okay, of course. You try to look cool, not copy paste, and then you made a basic mistake. Here we go. Okay, so we have the hello Greach up. Hello Greach. I don't use Emacs. I'm very old-fashioned. Oh, not yet. So let's create controller. Hello controller. I'm very old-fashioned. I use Midnight Commander. Yeah, it's the loosest thing you can use, but it works good for demo. So what do you want to just return? You know, some hello status. So let's return string. Hello Greach. You can just bind it to the root. No. So basically, only thing the very naive way how to deploy Micronaut application to Beanstalk is just to create your application and change the port number. Because by default, the Java application, if you deploy the Java application to Amazon Beanstalk, you have to either set the port in the environment variable, or the port 5000 is expected. So just server. $500. Okay. So we can run Gradle shadow var. This is not the, is Andres here? This is not using the gdub thing, it's just plain old alias for Gradle wrapper. Not the var file, sorry. Okay. And we can go to Amazon Beanstalk and create new environment. Which is going to be the Java environment. And upload the code. Lego creations, okay. Hello Greach. And just the jar file, it's okay. And now this is the reason why it's not a good idea just to do a demo of AWS services, because this will take a while. So I will just let it in here. We will just come back later on. Otherwise, probably, or do you want to see this for 5 minutes to deploy? 8 seconds. There are no instances. Okay, so this was the knife. I have some different example, but we can just do hello Greach here. And as I said, you just have to set the port. And I was just deploying manually. And actually, for the initial deployment, you have to do it manually and set up some kind of template for the rest of the applications. But when you set this up, you can just use this Beanstalk Gradle plugin, and you can deploy it automatically from your continuous delivery. You basically just say, okay, this is the endpoints I'm using, just to be called a Paris AWS. But you just take the shadow jar, upload it to this is name of application, this is name of environment. So in Beanstalk, you have an application which can have multiple environments. Are we lucky? Maybe. No, not yet. Not yet. Take a few minutes. No. So this was the most naive way how to deploy it. But the problem is if you do it this way, you, for example, can't set the useful system properties or JVM flags. I know if you, there's probably a couple of JVM flags you want to add to Micronaut application to make it work better. So the other way is you can just create, okay, another application, and if you can create some other files, which one is basically telling you don't want to run on the 500, so you don't have to update your application config. You just say, okay, this application is running on the port 800. And then you have this special file, which is called pros file. And then you just say, okay, I have a web application, and I'm running this application jar. So this is the other way how to deploy your Micronaut application to AWS. And of course, now this is the place. This is just basically bash command. So you can place there whatever JVM args you want to put there. And actually, I don't know why to do it, but you can have, you know, like a couple of applications in here. So if you are there and you believe Micronaut is small enough, you can deploy like 5 Micronaut application on a one Beanstalk. I'm not sure why to do it, but it's possible just to have multiple servers running here. And again, you can automate all the things. You just, you know, bundle your that pros file and that config file and the shadow jar and deploy it. It would be the archive, it won't be the jar anymore. And just to simplify the pros file, just set the archive name to specific one. I think some of the other Micronaut integration is doing something pretty similar. So it was Java. So it's pretty easy to run it as Java application. Give it another try. Hello, breach. Okay, so it works. So I was successful to deploy it. But the other way is also to use Docker. So you can use Docker to deploy your Java application. And actually, if you create new application, like this one, you already have your Docker file. So if you use the Docker, the gray Micronaut 1.2, 1.10 RC2 probably, you will also get this expose 880, which was missing in the last RC. But this is it. So this is the reason I believe that there is a lot of useful JVM flags you want to add because the Docker file has it. The other thing you can see is that it's using JDK 11. So if you just deploy as Java in AWS Beanstalk, you will have to go whatever is shipped with the Beanstalk, which I think still is Java 8. But if you want to use whatever Java version you want, you can use this Docker, and that's it. But the question is, just a bit more complicated to deploy it, but just a little bit. So Amazon is giving you a thing which is called Elastic Container Repository, which is basically the Docker repository you can use. It's already present if you have your AWS account. And there is a couple of Gradle plugin again, so you can use. This one is basically managing the ECR, the Elastic Container Repository. So you just have to say, okay, this is my repository, and I want to deploy this Beanstalk app. The prefix is always the repository, but I want to deploy this. And after that, if you push your image from your continuous delivery, you can have very simple file which defines your application. Basically, it just says, okay, use this Beanstalk application image from the content repository and expose this port or map this port to 80. So then if you upload it, if you deploy it, you can just run your application, a Micronaut application from Docker in Elastic Beanstalk. Yeah, again, you can just basically bundle that single JSON file in archive and deploy it from your Gradle file. So this was Beanstalk, and now the Lambda. So the main difference is that Beanstalk you don't have to think much about these servers, let's say in terms of EC2 AMIs, but you still have to think more about scalability. You have to set up your load balancer with the Beanstalk. You have to set up the minimum and maximum number of instances. And also you are always built, So for example, you always have your application deployed and you always pay for your Beanstalk application. But with Lambda, you only pay for the time spent. So for example, if you have application which is high peaks, so you need to really scale up in certain situations, you just can go for Lambda. And also, Lambda is not initially designed just to run web servers or web HTTP backends, but it's more about handling various events. So for example, this thing I was talking about is from the API Gateway. So API Gateway will take your HTTP request, translate it to some kind of JSON payload, which is sent to your Lambda, and the Lambda will respond with some JSON representing the HTTP response. But you can handle the Kinesis streams, you can handle sort of database triggers from the DynamoDB. So whenever you create new item in DynamoDB, you can handle it by Lambda. You can handle new messages in the queue. You can handle new uploaded S3 files. You can handle new notifications in the SNS topic. And of course, you can handle these. This is the cloud. This is Amazon CloudWatch, and it has this CloudWatch scheduled events. So basically, you can have a cron jobs with Lambda. And it's very easy to create Lambdas with Micronaut because it's exactly when you create new function. Hello Kitty. Is it Hello Kitty for GreatCon? Yeah. So basically, whenever you create new function in Micronaut without any feature flags, you create AWS Lambda function. And this is the example of very easy function. So if it's a Java function, it should implement one of the functional interface. For example, supplier. It could be function. It could be consumer, maybe. I don't know. So it's one of the functional interface. And this is created for you, the skeleton. So you don't have to think about. So this is the same as the name of the function. This is actually important. And you can do, dependency injection using constructor, and return anything. This is basically the same as was in the previous examples, showing the current environment names, whatever it's useful somehow. Okay, so and as I said, if you generate new function with Micronaut, it's already AWS Lambda enabled. So in the build Gradle file, I'm not sure about how you do it in Maven, but in the build Gradle file, you already have the way how to deploy it right ahead. So if you have your AWS credentials, you can just say, okay, Gradle deploy, and it will get deployed to AWS Lambda. Another thing which is really useful, so it's doable, but it could be pretty difficult to execute your Lambda code locally. But with Micronaut, you can easily run it as a HTTP server. So if you want to test it, you can even do some local mocks, and you can run it locally. And this is actually what's happening if you run a test. So if you create a test, and I think the test is created automatically for you when you create new function from the CLI. So you have this function client. This one is in the test pointing to the local embedded server, but it could be pointing to some existing Lambda function if you do the proper configuration. And this is nice. And in 1.1, this is really nice support for testing. Even nicer than it was before. So this injects the bean of this client, and you can just test it right ahead. It will know that it will to run the embedded server. It will know you are asking for this Lambda function. And you can invoke it You can invoke it using the function client. If you have some special use case, you can, for example, invoke it from Gradle as well. Just to be, let's say, just to be sure it's running, or just to do the first cold start or whatever. So these are some examples. This is the example of the API Gateway I was talking about before. So you have the event object, which is basically represented by some JSON sent to the Lambda function. So this is the API proxy request event, which is sort of HTTP request with the HTTP method, with the path. And now this is basically the same what was the controller before doing. So you check, okay, it's a GET request on the endpoint, and then if it matches, just do something, basically do the same. And again, you have to return some response event, which is going to be translated by API Gateway to, let's say, 200 or 500 and somebody. Who like it? No one. Yeah. And even if you try to have different endpoints, or handle doing the CRUD, so you have a get, post, put, update, it gets really ugly. So why we are doing this? We already have the controller. We have a controller. We can do it in the controller. We're doing this in this ugly way. Or you can handle the WebSockets. There's no better way yet. So the API Gateway can handle WebSocket. This is the other example of the function. But just get back to API Gateway and Micronaut. So starting from 1.1, there's the official support for API Gateway from Micronaut team, which helps you just to get the HTTP request from API Gateway, have a Lambda to handle it, and do the Micronaut magic in there. So again, what you can do, you can just create new application. And the only change here is it features AWS API Gateway, which is now present in 1.1. And again, you can just create simple controller as we did before, and that's it. It's using, what you can do, you can actually just bundle the zip file, upload it to Lambda, and set up the API proxy yourself. Or maybe you already have set up because you are doing the crazy stuff before. Or you can use this thing which is called serverless application model, which is kind of command tool you can use to either run it locally. So you can just start the application and you can run it locally. And it will handle the proper path. So if you go /n with a GET request, it will trigger the right controller. And then this is some tricks to upload it to AWS infrastructure, and it will create the API gateway for you. It will create the functions and whatever you want. So basically, there's no brainer. You can just call these 3 commands, and you have running HTTP. I wouldn't call it server, but HTTP endpoint based on API gateway and Lambda in a minute. And what's really nice, that starting from 1.1, you can also do this with Graal, with precompiled Graal environment. So even for Lambdas, you can create these API gateway endpoints or Lambda handlers using Graal VM, because even for Lambda, the cold start matters. If you have some crucial part of application when you want to respond fast, it's great to have really fast responses. As I said, you don't have to understand what's written here. You can just go back when you go to try it at home, but it really works. So you can deploy application or functions to using Graal VM. It will take a bit of time to precompile it, but you are just, as Graham said before, your compilation time will be longer, of course, but the runtime is much, much faster. Okay, so there are more support from the official documentation. One is Alexa. I don't have Amazon Echo at home, so I not play with Alexa. But if you're an Alexa fan, you can take a look. There's Route 55 service discovery, which could be kind of alternative to console or Eureka, I believe, and if you are using this one. And the last one, which I found pretty useful, is the parameter store. So if you want to centralize your configuration for your AWS application, either it's Beanstalk or it's Lambda, so you can set the parameters centrally in this parameter store. Let's say this is the setup for the Beanstalk application. This is some secure string, so you don't have to put the secure string in some environment variable configuration in your Beanstalk app or in your Lambda app. But you can just set it up. You can find it in the docs. And then you can just, okay, let's just scroll back. Okay, I have this Beanstalk app. It's not that visible, is it? But there's a Beanstalk app /conference/name. It's kind of convention to store it, which can be changed. And then you can just simply inject this conference name, and it's going to be read from the parameter store. It doesn't have to be in environment variable. It doesn't have to be fixed in the application.yaml. The only drawback is that, of course, this is going to be read when the application gets started. So it doesn't have any kind of, hot deploys or hot changes. But every time the application changes, you can start, it will read from the parameter store. And that's it. That's for the way how to run your Micronaut application on AWS. And I'll just take a look on this Micronaut AWS SDK libraries. So what is it? It used to be the Grails plugins. So if you're already using the Micronaut or the AWS SDK Grails plugin, you could be familiar with the libraries provided. So the origin is from the Grails plugin, but it's tried to be aligned to the Micronaut philosophy, which means there's a lot of these introduction, these AOP things. So there's a lot of clients, a lot of listeners and service introductions. It is Java friendly, so you can use it with Java as well, not like the Grails plugins. And of course, I'm the test guy, so it's easy testable. Let's start with really something simple. Well, everything is simple except DynamoDB on Amazon. And Kinesis is also not simple, it's just Kinesis. So simple email service, just the way how to send email from Amazon. It should be simple. And it is, this is the Java code, so what do? You have your service, you send an email, and you have the email definition with a subject, from, to, some HTML, and some attachments. I think this looks okay, but of course it looks much better in Groovy. And I think you can find out it's made by Sergio. I think it was contributed by Sergio, because he's still in the test. Other one, simple storage service. No one is probably, especially on the cloud, storing the uploaded files in the /temp something. So what do? You just upload it to S3, store it somewhere. So this is the way how to basically store files, binary, whatever files in Amazon. You can create a thing which is called bucket. Bucket is just a bucket of files. It's a kind of top-level directory, how to call it. So you can use the service to create the buckets. You can upload files, so store file, upload it. You can list the object. This is useful, so you can generate a pre-signed URL. So if you upload it, it's secured. No one has an access except you or whoever has the credentials to download it. But if you want from your application to download it, you have to generate this pre-signed URL just for your user, and he or she will be able to download it. And yeah, you can download it from your application. You already have the rights. And of course, you can delete files you don't want to use anymore. Okay. Now the kind of complicated topic, not because the implementation, it will be really, really easy to use, or the library services which is provided, but just to distinguish. So this is simple queue service, simple notification service, and Amazon Kinesis. And how to use them. So simple queue service, it's a queue. The core feature is that you have a queue and you have a one single consumer of the queue, which is going to grab the message from the queue, delete it, and handle it somehow. On the other hand, simple notification service is the PubSub model. It's a publish subscriber. So you publish items, records, and the notifications, messages in the topic, and you have multiple endpoints, multiple subscribers, which could be Lambda function, it could be webhook, and it could be even email. It could be even some push notification to your device, which Android device or iOS device. And also, this is the service which can send SMS from, if you are keen to send SMS text messages from Amazon, you go for this one. Last one, Kinesis streams. They are supposed to handle, like real-time data, which could be, as you can see, the application logs. It could be like social media, new social media posts, for example, if you follow some hashtag or whatever. Cool. So this is just some to distinguish these three services. So you have to basically pull from the queue, if just continuously pull from the queue if there is no items available, and only one application or handler should handle the event, the message. You can have multiple recipients for SNS. You can do mobile push, send text messages, and for Kinesis, you basically handle the data streams. It could be binary. And the drawback is you have to manage the shreds, so you have to say how to split the work for Kinesis. So now how the library support looks like. So if you, for example, seen the Kafka client for Micronaut, it's basically the same. So you just declare an interface. You say, okay, this is the queue client. You can somehow modify, for example, which configuration to use, which queue to use. But you can send message, and you can send message in various ways. So it could be just an object which is going to be converted using JSON as a JSON file. It could be just a plain string, or there are some other options. For example, you can say in what delay in a queue. And if you're using the FIFO queue, which is kind of new feature, you can send in which group of FIFO queues to send it. And if you handle this manually, if you handle the messages manually, there's basically all the methods you implement are going to send something, depending on the signature of the method. But you can also delete message with the message ID. So this is what you do if you grab a new message from the queue. You just say, okay, this is my message. I will going to delete it and handle the message. Just for this first one, I'm just going to show you how to test it as well. So it's pretty nice integration with test containers. So there is a thing which was originally from Atlassian, which is called local stack, and it provides local mocks for a lot of Amazon services. So you can, for example, say, okay, I want to run SQS mock, and this basically runs the Docker image. Therefore, it's using test containers. So this will run the Docker image for the time of the test, and you can create new service using this mock and inject it into your application context. And once it's in your application context, basically all the calls to this service is going to the mock instead of the real endpoint. So simple notification service, and this is going to be kind of déjà vu section of this session, because okay, it looks exactly the same, most of it. Again, The only major change is you have the notification client, and you can alter the topic, not the queue. But again, you can send the message, publish message as the, any object, which is able to be converted to JSON using JSON. Then the only other thing is that you can use a subject. The subject is used by some of the handlers, like the email. So if you send an email, if you have an email subscriber, you can just publish, okay, this is the subject of the email, this is the message of the email. And also, most of the messages are handling just publishing, but they are too special. So whenever there is SMS word in the name of the method, you can send the messages from this client. Okay, so as I said, you can use push notification to devices. So this is not that nice yet, but for example, you can use this service to register new device and to send the up notification from SNS. And the last one, Kinesis, and again, what do? We just do the Kinesis client and the magic happens. And again, there's the different ways how to publish or put the records. They're putting the records. The only special thing is that you can have the partition key and sequence number. This is specific to Kinesis, and the partition key is basically the key which helps you to split the workload. But otherwise, it could be string record, it could be byte array, so some binary record. It could be POGJO, and some magic will happen. Some unique key is going to be generated for the POGJO. Well, and what you can also do, I'm not sure if I should suggest it to you, because I think probably the best way to do it is just to create the Lambda handlers, Lambda function. But if you want to handle the new items in the Kinesis streams, you can create a singleton bean and create a Kinesis listener and listen to the new records in the stream. And again, you can use different signatures. It could be the kind of native record, it could be an event, it could be just plain string. Okay, the last one. Amazon DynamoDB is, sorry, I just took this from the website, so it's kind of marketing. So it's, awesome database. It's the core thing is a document database. So, what is it using underneath? It's kind of thing like DynamoDB mapper, and it comes with this annotation. Just say, okay, this is the entity. It uses this table, call it entity. You always should have the hash key of your entity. Optionally, you can have the range key, which could be used, for example, for a sort. And whenever you want to query by a property, you should have an index for it, so you can declare the indices or whatever. And this is again inspired by Gorm, but it is limited yet powerful. We'll see it later. So this is just the basic operation. So you can just get the entity by hash or by the RH key. You can save it. You can count how many entities with the hash key is present in the database. Even you shouldn't do it because it's quite a cost operation. Anyway, this is the possibility you can just get if you annotate just a plain Java interface with service and the entity you're going to use. Who's familiar with Gorm here? So there are no dynamic finders in this implementation because, I don't know, it's pretty difficult to do it in this kind of different way how to query things in the document DB. I know Mongo is using it, but what you can do, you have some different DSL to say, okay, I want to query DynamoDB entity with this hash key, which is the parameter over here, and this with the range query, and this range key is equal the name of the index is equal to this range key, and I only want to return the range index from the query. So this is going to be the DynamoDB entity, but it will be only populated with the range index. So this is the way how you can basically create whatever query supported, but you have to think about it does have the index. And if it does not have the index, sorry, this is the other. So that was, of course, this was the Groovy example with the closure. But as I said, the library is now Java friendly. So this is not that nice, but you can declare a class which implements the signature. And you can use the same builder, but with Java. So okay, scan, this is using scan, filter, it equals, the range index equals whatever I get as a foo. So yeah, Groovy is still a bit better, but this is the advantage of this is that you can reuse it easier. So for example, if you have a scan and count, you can use it the same class. So these are the scans. Scans are, you have to scan for the properties which are not indexed. You have to scan, which is a bit more pricier. And the last one, what you can do is to have some kind of fine-grained update. So you don't have to, just load the item, make a change, save the item. You can do this update, for example, an increment. So what does this do? Is just say, okay, I want to find the DynamoDB entity with the hash, which is hash key, with the range, which is the range key, and add the number 1 to property number. And what I want to return is the new value of the number. And this is going to be implemented for you underneath. So this is the method you can use. You can mock it easily, but this is implemented for you using the Micronaut introduction under the hood. And that's it. So we took a look on how to deploy to Beanstalk, how to deploy to Lambda, either as a function, as a handler to some trigger, or using the API Gateway integration, which can leverage more the Micronaut HTTP features. And then we just take a look on how to send emails, upload files, do some messaging, and store data with DynamoDB. So thank you. Any questions?
Questions?
For that?
What?
Probably not. Okay.
No questions?
No questions? Okay, so I'll be around for the rest of the conference. So thank you.